Hi students. Now we'll discuss about AC bridges and its balancing condition and some important points regarding to AC bridges. First of all, we will discuss the balancing condition of AC bridge. Here we have already discussed the balancing condition in case of DC bridges. Here it is the existence of AC bridge. Here the difference is here we are using one AC source and meter as a detector, and all are represented in terms of impedances Z1, Z2, Z3, Z4. These are the impedances in the four arms. Is the first arm, second arm, third arm, fourth arm. Four are the impedances. Now here to derive the balancing condition, we have to assume the bridge is in balanced condition. Bridge is in balanced condition. Bridge balanced condition means here no current flows through this galvanometer. No current flows through this galvanometer. That means the entire current will be comes in this path. This means I1 will be continuous and it will be continuous. I2 will be continuous and it will be here like that. That is the point. So initially these two branches are in parallel. So voltage at this branch is equal to voltage at this branch. That means voltage at first branch is equal to voltage at second branch. So according to Ohm's law, voltage at first branch is I1 Z1 is equal to I2 Z2. Let it as equation number 1. Equation number 1. So in case of bridge balancing condition, I1 equal to I3. I1 equal to I3 because no current flows through galvanometer. Sorry, detector. So I1 is equal to I3. That is equal to I equal to applied voltage E into E by total resistance, that is total impedance here Z1 plus Z3. And similarly I2 equal to I4 equal to E by Z2 plus Z4. Substitute these two values in equation 1. So I'm getting here Z1 into, instead of I1 I'm substituting this E by Z1 plus Z3 is equal to Z2 into E by Z2 plus Z4. These two terms will get cancelled. So this one letting this side, this one letting this side. So Z1 into Z2 plus Z4 equal to Z2 into Z1 plus Z3. By multiplying here Z1 into Z2 plus Z1 into Z4 equal to Z1 into Z2 plus Z2 into Z3. Here these two terms will get cancelled. Then Z1 Z4 is equal to Z2 Z3. It is called as bridge balancing condition in AC bridges. Bridge balancing condition. Balancing condition. It is the condition. Now, to analysis in any AC bridge, we have to follow some specifications, some standards existences. That means simply R. Look at here. These are the very important points. Very important points you have to remember in case of DC and AC point of view. In case of DC, R. R can be represented as R. And AC can, in case of AC, the resistance can be represented as Z. Here the impedance, when we're having resistor in any arm, the impedance can be equivalent to resistance. When we have capacitance C, when we have capacitance C in any arm, the equivalent impedance is Z equal to minus J by omega C. When we have inductance in any arm, then the equivalent impedance is Z equal to J omega L. J omega L. When we have the parallel combination of R and C, then now we had to choose admittance. Y. Y is equal to 1 by R plus J omega C. It is the equivalent value. Next, when we have resistance and capacitance are in series in any arm, then impedance, equivalent impedance Z is equal to R minus J by omega C. When we have resistance and inductance are in series in any arm, then equivalent impedance Z equal to R plus, here it is R, plus for the inductance J omega L. Here R plus L. R is for R for L J omega L. R plus J omega L. Similarly, R plus C. R value is R. C value is minus J by omega C. Like that we are presenting. These are the notations we have to remember in case of AC bridges point of view. In any AC bridge, we have to remember this. When the arm is consisting only resistor, then Z is equal to R. When arm is consisting capacitor, then Z equal to minus J by omega C. When arm is consisting inductor, Z equal to J omega L. When arm is consisting R parallel C, that means resistor is in parallel with capacitor, then Y equal to 1 by R plus J omega C. When arm consisting of resistor and capacitors are in series, then equivalent impedance Z equal to R minus J by omega C. When arm consisting of resistor and inductor are in series, so equivalent impedance is Z equal to R plus J omega L. For example, for example, if in fourth arm, in fourth arm, in fourth arm, R and C, R and C are in parallel. Parallel. Fourth term. In fourth term, we are having R and C. So, in fourth term, R can be represented as R4, C can be represented as C4. So, equivalent value. Look at here, R and C are in parallel. This is the value. So, Y4 is equal to 1 by, here R value is R4 plus J omega C value is C4. Like that we have to represent. For example, for example, in the second arm, the second arm, R and L are series. R and L are in series. So series means second arm na, here it is second arm. So in the second arm, R can be written as R2, L can be written as L2. L2 second arm. So R2, L2. So look at here. R and L are in series. That means R plus L. So this value will becomes as Z2 second arm, since second arm. Z2 equal to R value is R2 plus J omega L2. Like this we have to represent. That means by depending on the arm, the corresponding value has to be changed. The corresponding value has to be changed. By depending on the arm value, we have to represent the corresponding values. It is very, very important. while discussing all the AC bridges. Very important points.